All right, so October the 16th, 2020, we're looking at roots of a polynomial. And here we're told that the remainder theorem and the factor theorem holds for complex number as well as real numbers. If a polynomial equation has complex roots, then one, if all the coefficients are real, the roots occur in conjugate pairs. All right, so we'll get a chance to see that in action. What it's saying is that if all the roots are real, if the coefficients are real, then the roots occur in conjugate pairs. What else? A quadratic factor of the polynomial is. All right, so I think even the very first time I read that, it was sort of, I'm trying to figure out exactly what the man was talking about. So let us say your roots of your polynomial are alpha and alpha conjugate. If those are your roots, it means that z minus alpha and z minus alpha and z plus alpha, or sorry, z minus alpha and z minus alpha conjugate are factors. Now, when I made that statement, does that make sense for you? So, for example, if I'm saying to you that z is equal to alpha and z equal to the conjugate of alpha are roots, it means that z minus alpha and z minus the conjugate of alpha are factors. Does that statement make sense to you?
Yes, sir.
Yes,
All right,
sir.
good. Now, it means therefore that, so z minus
Sir,
alpha,
excuse me, sir.
yes, go ahead, Jamila.
Repeat the statement, please.
I said, this was the statement, if z is equal to alpha and z is equal to the conjugate of alpha are roots of a polynomial, that z minus alpha and z minus the conjugate of alpha are factors of that polynomial. Then I asked if that statement makes any sense. And Persis said yes. You want to throw in your opinion in it?
Okay, sir. Thank you. No, sir.
All right. So it means therefore that if z minus alpha and z minus the conjugate of alpha are linear factors, by multiplying them together, I could get a quadratic factor. So z minus alpha multiplied by z minus the conjugate of alpha. If I multiply that, I'm going to get, let us say, z squared. And this is minus z alpha conjugate minus z alpha, a negative times a negative is a positive, alpha multiplied by alpha conjugate. All right. Now you see this, what I'm doing here is related to this statement. It's related to that statement. All right, so you can see that what we're going to have here is what? Z squared minus, let us say, alpha plus the conjugate of alpha, z plus alpha conjugate. And if you examine that statement carefully, you'll see that it is the same statement that is made in I. Because alpha plus alpha conjugate will give you 2 times the real part of alpha. And alpha multiplied by alpha conjugate will give you the modulus of the square of alpha. It will give you the modulus of the square of alpha. All right, just write it down. Don't stress it too much. You can look at it if you want to. As I showed you yesterday, I'll actually send the notes. So I would say try not to stress yourself in terms of trying to take notes now. But if you can do it, if not, just leave it until later and let us see if we can get through the lesson. Does that work for everybody?
Yes, sir.
All right, so I'm going to the next page. Let us see if we can try and see some of these things in action. All right, example 10 says, solve the equation z squared plus z plus 1 is equal to 0. All right, well, I'm going to solve this equation using the quadratic formula. It's a quadratic equation. I'm going to use a quadratic formula, which says that z would be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So the coefficient of z squared would be a, the coefficient of z would be b, and c would be 1. So it means here that z would be equal to minus 1 plus or minus the square root of 1 squared minus 4 times 1 times 1. And this is all over 2 times 1. We're going to end up with minus 1 plus or minus the square root of 1 minus 4 all over 2. So we're going to end up with z is equal to minus 1 plus or minus the square root of minus 3 all over 2. Z is equal to minus 1 plus or minus the square root of 3i all over 2. So this root minus 3 is the same as saying root 3 times root minus 1. And root minus 1, as everybody knows, is I. If I want, I could separate this and say z would be equal to minus 1 plus root 3i over 2, or z is equal to minus 1 minus root 3i over 2. All right, so if you solve a quadratic equation, you must get two answers, 1 and 2. I want you to know that the coefficients of z are all positive.
Sir, your audio went out or something.
I know. I don't know what's happening. Is this? I got a new computer, and from I got this new computer, every now and then it does that. All right. So I want to just get back to a statement that was made earlier. The statement says, if all the coefficients are real, the roots occur in conjugate pairs. Now, if we get back now to the example, we'll notice that all the coefficients of z are real, and we notice that the answers, which are the solutions of the equation, which are the roots, we notice that they occur in what? In conjugate pair. One would be minus a half plus root 3 over 2i, and the other is minus a half minus root 3 over 2i. The roots occur in conjugate pairs. All right, with that in mind, guys, I would like for you to look at example 11. All right, so let's do example 11. So next patient, sort of same treatment. Z would be equal to minus B. So that's minus 2 plus or minus the square root of B squared, which would be minus 2 squared, minus 4 times A, which is 1, times C, which is 2. And this is all over 2A, which is 2 times 1. A negative times a negative is a positive 2, plus or minus the square root of minus 2 squared is 4, minus 8, and this is all over 2 times 1, which is 2. It is kind of a little too long. All right, so what we end up with is 2 plus or minus the square root of minus 4 all over 2. This is 2 plus or minus root 4i all over 2. So therefore, Z would be equal to 2 plus or minus 2i over 2. So Z would be equal to 1 plus I, or let's spell it out. Yeah, 1 plus I, or Z is equal to 1 minus I. Any problems? Any problems from anybody?
So
No,
I
sir.
had negative I, but seeing that, because I looked back at the example when we were doing the i's, and we had like I to the power of 5, and we had I square and then I, so I figured it'd be negative I, but I guess.
Okay, let me just tidy up the ending part here a little. I'm going to say that this is Z is equal to 1 plus or minus I, because they divide both by 2, and so Z would be equal to 1 plus I, or Z would be equal to 1 minus I. Whenever you solve a quadratic equation, you must get 2 answers. Please note that all the coefficients are real and that the roots are in conjugate pairs. All right. So let's have a look at example 13. So in example 13, we're asked to solve this quadratic equation. Please note that the coefficients are not all real now. Now we have a complex coefficient. So let's see what's going to happen. Do number 13, please. All right, so example 13, let's have a go at it. All right, so we need to solve this using the quadratic formula, because this is a quadratic equation. Z would be equal to minus B, but B would be the coefficient of Z. B would be the coefficient of Z, which is minus into 3 plus 5i. So that's minus B plus or minus the square root of B squared. So that's minus into 3 plus 5i. And we need to square this. Minus 4 times A, which is the coefficient of Z, which is 1, times C, which is the section of the thing of the equation that don't have any Z to it. So that's 2 plus 5i. And all of this now is over 2 times 1. All right. So let's work down. A negative times a negative is a positive. So this is positive 3 plus 5i. Here, this is plus or minus. We're going to square 3 plus 5i. Please note, what can you tell me about minus 2 square?
Just 4?
Sir, it's positive.
I'm coming. What can you tell me about minus 2 square and 2 square?
They're both positive.
They're both positive 4. So if I have a negative of a number or the positive of a number, if I square them, the answer is going to come out to be the same. So minus 3 plus 5i squared is the same as 3 plus 5i squared. Do you agree?
Yes, sir.
So if it is negative or positive, the square is going to come out to be the same. So I could just simply work this as 3 plus 5i squared. Whether it's negative or positive, the answer will come out to be the same. Minus 4 into 2 plus 5i. Stay with me. This is over 2. This is 3 plus 5i. I can find out sometime this pen does give me a problem. Getting a better one. So this is 3 plus 5i plus or minus the square root of. Well, if I square 3 plus 5i, I'm going to get 9 plus 30i plus 25i squared. Do you agree?
Yes, sir.
When you square something, you multiply it by itself, you know. So it's just, I'm simply multiplying two binomials. Minus distributive law, 4 2s are 8. And 4 5 is what? 20i. All over 2. Now all I need to do is simplify. Simplify whatever I have under the bracket. This is 3 plus 5i. I don't think this question is for the faint-hearted. Now the square root of, this is 9. 25i squared is the same as saying minus 25. Do you agree?
Yes, sir.
All right, minus 8. So I'm dealing with all the numbers. Then I have 30i minus 20i. So that is what? 10i.
So,
Go ahead, ask your question.
so where the 25 came from again? The 9 minus 25, that part.
25i squared. I squared is minus 1. So 25 times minus 1 becomes minus 25. Is that clear?
Yes, sir.
All right. And this now is still all over 2.
Sir, isn't that supposed to be, oh, that's 10 minus 30 minus.
We're still good?
Oh, sir, because for mine I had 30 plus 20.
It's actually minus 20. Because when you apply distributive law, a positive times a negative give you a negative. 4 5s, 20i. So 30 minus 20 is 10. So what we have now is we're going to have 9.
Oh, sir, I forgot the negative. So I did just put down back the negative sign. I just multiplied it by the 4 and put down back the negative sign. That's what I did wrong.
All right. So here we have what is this? Minus 26? Not minus 26, minus 24?
Yes, sir.
Not 9. Sorry, 9 minus 1 is 9 minus 8 is 1. 1 minus 25 is minus 24. So turning to the next page. What we have is Z is equal to 3 plus 5i, positive or negative, the square root of minus 24 plus 10i. Do you agree? And this is all over 2. Tell me if you agree, please.
Yes, sir.
Yes,
All right.
sir.
Yes, sir.
Now, what we need to do is that we need to find the square root, and this is what many of you probably probably didn't remember how to do.
Sir,
We need to find the square root of this, the square root of a complex number, which you learned how to do yesterday.
sir,
Uh-huh,
can I tell you what I did when I reached there?
uh-huh.
What I did is separate the equation and put root 24 to itself and then add it to root 10i, change the negative 20.
No, that is not something you can do at all. It's not mathematically correct.
I was taking out the root, the negative 1 root and putting high where 24 is.
Yeah, man. Fine, I hear what you did, but what you did is not mathematically correct.
Okay, sir.
There's no correct mathematics that would allow you to do what you just suggested. You see, if it was a multiply between the 10 and the I, you could have done that. But because it's a plus, you can't. That makes it not mathematically correct. And so what I'm about to do now is what you should have done. Call this X plus IY. This is the last thing we did yesterday. Then I'm going to square both sides.
Makes sense.
Square both sides. Then I'm going to end up with what? Minus 24 plus 10i would be equal to x squared minus y squared plus 2xyi. Still working, guys, don't worry. X, y, I. Next, we're going to equate coefficients. Sorry, equate real and imaginary. Real on the left must be equal to real on the right. So real on the right, which is x squared minus y squared, would be equal to minus 24. Imaginary on the right, which is 2xy, is equal to imaginary on the left, which is 10. Divide both sides by 2x here to find out what y is. And I'm going to get y is equal to 5 over x. I'm going to then substitute this value of y into equation 1, and that will give me x squared minus 5 over x squared is equal to minus 24. I'm going to end up with x squared minus 25 over x squared is equal to minus 24. Then I'm going to multiply the entire equation by x squared. To get rid of the fractions, I'm going to end up with x squared multiplied by x squared, making it x squared squared minus 25 is equal to minus 24 times x squared. Any problems with that step?
No,
All
sir.
I did was multiply the entire equation by x squared. All right, this is quadratic, so I'm going to have x squared squared plus 24x squared minus 25 is equal to 0. I'm going to let x squared be a. So now I'm going to have a squared plus 24a minus 25 is equal to 0. I'm going to solve this using the method of factorization. This is a 25, 1, positive and negative. Therefore, a minus 1 is equal to 0, or a plus 25 is equal to 0. Therefore, a is equal to 1, or a is equal to minus 25. Remember, a is x squared, so x squared is equal to 1, and x squared is not equal to minus 25. And the basic reason for that is that whenever you're finding the square root of a complex number, the value of x and y must be real. And the square root of -25 is not real. So that is why we have to reject that answer. So therefore, x is equal to positive and negative, the square root of 1, which is just basically saying positive and negative 1. So I have the values for x. What I need now are my values for y. So remember that y is equal to 5 over 25. So y is equal to 5 over 25, over x. Sorry about that, 5 over x. So when x is equal to 1, y is equal to 5 over 1, which is 5. And when x is equal to -1, y is equal to 5 over -1, which is -5. So it means, therefore, that the root of -24 plus 10i would be equal to x, which is what? Which would be equal to x, which is 1, plus iy plus y, which is 5. So this is 5i. Ignore the negative and the positive, and I'll show you why. It means, therefore, that z is equal to 3 plus 5i, positive and negative. So that's where the positive and negative comes in. 1 plus 5i. Because that's what we just worked out, the square root of -24 plus 10i to be. And this is now all over 2. We just need to simplify. Z is therefore equal to 3 plus 5i plus 1 plus 5i over 2, which is, this works out to be 3 plus 1, 4, 5 plus 5 is 10. So this is 4 plus 10i over 2, which works out to be 2 plus 5i. That's one of the answers. The next answer, z is equal to 3 plus 5i minus 1 plus 5i, and this is over 2. Z would be equal to 3 minus 1 plus 5i minus 5i, and this is all over 2. Z would be equal to 3 plus 1 minus 1 is 2. 5i minus 5i is 0. So it's 2 over 2. And here the answer is z is equal to 1. Once you have the two values for z, this question is finished. So I can say z is equal to 2 plus 5i, and z is equal to 1. Those are your two answers.